solve the equation 2p cubed equals 2p times p plus 2 by factoring. Now you look at this and you say, wait, solve it by factoring. It's already factored. What do we have to do? Well, the reason why this factoring word is perhaps more work than it looks like is even though this is in factored form, this form does not help us. The reason factored form helps us with a polynomial is if we have a polynomial and we can write it as the product of a few things, and if that product is equal to 0, then I know that either this first piece has to be 0, or that second piece has to be 0, or the third piece has to be 0, or if there's more pieces, the fourth piece, fifth piece, etc. Right? So it lets us take this big expression and simplify it into a smaller one, into a smaller one, into a smaller one. So instead of one big expression, we have a few smaller, simpler to solve equations. Right? That works if I have factored form equals 0. Here I have factored form equals another polynomial, in this case another factored form, it's a monomial. Right? But that doesn't help us with this sort of case. We have factored form equals something that's not necessarily 0. So we have to do a little bit of work. So I have to undo the progress we've already made, or the progress we've already given to us in factored form. I have to undo that factored form, get everything on one side of the equal sign, take that new polynomial and try and factor that, and that way I'll have this factored form equals 0. So why don't we go ahead and multiply out 2p times p plus 2. So that gives us a 2p squared plus 4p. And now we could go ahead and subtract 2p squared from both sides. And we could subtract 4p from both sides. And now we have polynomial equals 0. So that's step 1. Polynomial equals 0. Now we have to write that polynomial as a product. So to do that, we need a factor. I look at this polynomial. I notice there's a p in each term. I notice that each of my coefficients is even, so I can factor out a 2p. So that's nice and helpful. If I factor out a 2p, I'm left with a p squared from this first part. Take a 2p out of 2p squared, I'm left with a negative p. I take a 2p out of negative 4p, I'm left with a negative 2. That thing equals 0. So we got a bit more of our factoring done. Here's another polynomial. Does this factor sum? We notice, yes, indeed it does. We just need to find two factors of negative 2 that sum to a negative 1. Negative 2 and positive 1 happen to be two factors of minus 2. Minus 2 times positive 1 is negative 2, where negative 2 plus 1 is equal to negative 1. So we have a p times 1 and a negative 2 times p. That gives us our negative p. The negative 2 times positive 1 is negative 2, and p times p is p squared. So there's the factoring of this polynomial. So now I can take this factored form, and I know that either this first part, 2p equals 0, or that second part, p minus 2 equals 0, or this third part, p plus 1 equals 0, right? And so now I can solve each of these simpler equations. 2p equals 0, divide both sides by 2, I get p equals 0 divided by 2, or 0. This next part, p minus 2 equals 0, add 2 to both sides, I get p equals 2. This third part, p plus 1 equals 0, subtract 1 from both sides, I get p equals a minus 1. So here are my three different answers to this original equation, 2p cubed equals 2p times p plus 2. And there we go. So we solved it by factoring, but first we had to undo the factoring that we started with so that we could get polynomial equals 0, and then we factored that polynomial. This factored form, no good.